In this question, we are given a five-sided polygon, which kind of looks like a house and is made up of a rectangle and a triangle. We're given some information about it, including the perimeter of the entire shape. We are asked to show a formula for the area. We are then asked to find the maximum possible area, giving it in surd form, and to explain why we have a maximum value. So let's look at this shape in more detail and let's label it. It's always a good start for a question like this is to fully label the diagram with all the information we are given. Now we know that AB is X and ABCD is a rectangle, so DC is going to be X as well. We know BC is Y, so AD will be Y. And it tells us that the triangle CED is equilateral, so we know that this distance DE is X and this distance EC is X. It tells us it's not drawn accurately, so we can clearly see that the angle here must be 60, 60, 60 because it's an equilateral, even though it's drawn to look like it's a 90-degree angle at the top. It's not, because it tells us it's equilateral. Now the question tells us the perimeter for the entire shape is equal to 100. So let's write an expression for that. So we're going to look at the perimeter first. And we would say that 100 equals, let's start at the top, we've got x plus y plus x plus y plus x, so that's the distance all the way around the outside. Let's tidy that up just a little bit, so we've got 100 equals to 3x plus 2y. Now looking at what they're trying to get us to create in the show that, our area is in terms of x, there's no y here. So what I'm going to do now is just rearrange this equation for the perimeter so that I actually know what y is equal to, because clearly I'm going to have to get rid of that y at some point. So that's going to be 100 minus 3x is 2y. So y is 100 minus 3x over 2. I'm going to call that equation number 1. So next thing, let's look at the area of the two shapes, the two composite shapes. Let's go for the rectangle first. So we want the area of the rectangle. That's ABCD. And the area of the rectangle will simply be base times height. So that is x, y. And I know that y can be represented by 100 minus 3x over 2. So let's put that in. So my rectangle area will be x multiplied by 100 minus 3x over 2. So I'm substituting equation 1 into that. And let's leave it like that for the moment. So I have my area of my rectangle purely in terms of x. Let's look at the triangle. The area of my triangle now, this is DEC. And the area of that is the half base times height. So it's half multiplied by the base multiplied by the height. What is the height? Ooh, I don't know. Let's have a look. So the height will be this distance here. So let's just redraw that slightly. Let's just take a little triangle here. And I've got E, C, and I'm just going to maybe call that M as a midpoint. Okay, that's going to be the midpoint here. And I know that this distance is x, this distance is going to be half of that, so it's x over 2. So it's a Pythagoras question to work out the height. I want to find out what my height is here. So I know, I'm going to do this on the left-hand side here, I know that h squared plus x over 2 squared will equal x squared. So h squared equals x squared minus x over 2 squared. H squared is equal to x squared minus x squared over 4. So I've got x squared minus a quarter of x squared. So my h squared is going to be equal to 3/4 x squared. And I'm going to want to square root that. So my h will be equal to the root of 3/4 x squared. And this will simplify further. So this becomes the root 3 multiplied by x over 2. I square root the 4, square root the x squared. So I've got root 3 x over 2 is my height. Let's put that back into my equation for my expression for the area of the triangle. So a half x times h is going to be equal to a half multiplied by x multiplied by root 3 x over 2. And that then gives me, let's look at this, I'm going to have root 3 over 4 multiplied by x squared. And so that's the area of my triangle. So the total area of my shape, which is called R, so R must equal the two areas put together. So it's going to be the area of my triangle plus the area of my rectangle. So let's do the rectangle first. X 100 minus 3x all over 2 plus root 3 over 4 multiplied by x squared. Now let's try and tidy this up a little bit. I've got R equals x multiplied by, I'm going to do 100 over 2, which is 50, minus 3 over 2x, plus the root 3 over 4x squared. Need a bit more space. So looking at this, I have, at the moment I have two terms, both with x in. So let's factorize. So R will be equal to x, and then I'm left with my 50 minus 3 over 2x plus root 3 over 4x. I don't really need those curved brackets in there now because I just got things that are added or subtracted. So let's just go back and remove those. So I don't need that, and I don't need that. And looking at the question, it has x over 4 outside of the bracket. So what I need to do now is get to a point where I have x over 4 here and see what that does to my bracket. So if I had a quarter out, I got to make everything inside 4 times as big. So I would have 200 minus 12 over 2x plus root 3x. Take a second to look at what's happened there. A quarter of 200 is 50, a quarter of 12 over 2 is 3 over 2, and a quarter of root 3 is root 3 over 4. Now looking back at the question again, I have my x over 4, I have my 200, but I need to have this expression here, minus bracket 6 minus root 3 close bracket x. So I need to factorize this where I have minus x outside of the bracket. Let's give ourselves a little bit more space and let's see what we can do. So I'm going to leave the r alone, the x over 4 is fine, the 200 is fine. And then looking at these two terms here, I want minus and x outside. I'm going to put them both at the front, which will be perfectly fine. So I've got to factorize it by minus x. So 12 over 2 is just 6. So I can put 6 here, and I factorized the first part. And then I have root 3 plus root 3x, but I want to factorize by putting minus x outside. So I'm going to make that minus root 3. Might seem a bit strange, but let's just look at it in review here. If I did minus x times 6, I'm going to get minus 12 over 2x minus 6x. So that works. If I do minus x times minus root 3, I get plus root 3x. Now this is exactly the same as this. Okay, the x is in the wrong position, but that's fine. It's still multiplied, so that's okay. I've got curvy and square brackets the other way around. That doesn't make any difference. This is good enough to show that I have got my correct area. In the second part of the question, they ask for a maximum value. So this will involve differentiation. Looking at my equation, I have r equals x over 4, 200 minus 6 minus root 3 x. Going from here, we've got r equals x over 4, 200 minus 6x plus root 3x. That then gives us 200x over 4 minus 6x squared over 4 plus root 3 over 4x squared. And that will then give us 50x minus 3x squared over 2 plus root 3 over 4x squared. Differentiating dr by dx is the same as differentiating dy by dx. So let's do this. Dr by dx, 50x is going to become 50. Minus 3x squared over 2 is going to be minus, the 2 comes down as from the power, so it's 2 times 3x. We drop 1 off the power, so it's not x squared, it's just x, and that's over 2. Plus, the 2 comes down from the x squared again, so we have 2 root 3 over 4x. Let's tidy this up. So we have 50. These 2's cancel, so it's going to be minus 3x. That 2 will simplify with that, so we have plus root 3 over 2x. And we want to put this equal to 0 because we're trying to find a maximum value. We're trying to find where it would turn on the graph. So we can put it equal to 0, and we want to solve this. Let's multiply through by 2 because that gets rid of my fraction there. So 0 equals 100 minus 6x plus root 3 multiplied by x. Now I'm going to factorize the x part at this point. So I'm going to say 100, so 0 equals rather 100 minus x. So I'm going to factorize with minus x. 6 minus root 3. Now the reason I've chosen to do that is because the question asks it to be in the form of p over q minus root 3. So I want to have a minus root 3 in here somewhere. Now let's solve this equation. We have only one unknown, which is x. I'm going to add the x 6 minus root 3 to both sides to make it positive equals 100. So x will be 100 over 6 minus root 3. And now I've got it in the form that I wanted. The question wanted it in the form of p over q minus root 3. So clearly we can see p equals 100 and q equals 6. The final part of our question is fairly straightforward. It says, why is x going to be a maximum value here? Well, if we look at the original equation, and I've expanded it here, we look at our squared term, our x squared term, it is negative. So when we put it equal to 0 and we plot it, we're going to have a graph that looks something like that. It's going to be an upside down shape. So when our value is equal to 0, that is our maximum. So all you need to say is R is a quadratic with a negative coefficient of x squared. You don't need to draw it, you don't need to work out any of the algebra there. You identify it yourself by looking at the equation, and that's your statement, and that gets you the full marks.